Today we are started about the first unit, the transmission and distribution of electrical power. The unit one is transmission line parameter. The previous semester we are studying about the generation of electrical power. The generation of electrical power, that is, it is classified for two types of generation. One is for the conventional power plant, another one is for the non-conventional power plant, another one is for the another name of non-conventional power plant is renewable energy sources. Renewable energy sources. In conventional power plant, we are studied about thermal power plants, nuclear power plants, hydroelectric power plant, the gas and then diesel power plant. Actually, in that the power plant, we are generating the power in terms of 3.3 kV, 6.6 kV, 11 kV, 3.3 kV, 6.6 kV, and then 11 kV. In thermal power plant, the fuel we are used for coal. In the nuclear power plant, the fuel we are using for uranium, thorium, and then plutonium. In hydroelectric power plant, we are used for water. In the diesel power plant, we are used for the diesel, petrol, so on, etc. In the gas power plant, we are used for the natural gas. Once we are generated the power in the power plant, generally the power plant is constructed far away from the consumer. The power plant is constructed far away from the consumers. And the renewable energy sources, that is solar power plant, the wind, biomass, geothermal, tidal, so on, etc. Either in the conventional power plant or non-conventional power plant, once we are generated the power, immediately we need to send to the consumer via transmission and distribution line. Via transmission and distribution. There is no other options are there. There is no other options are there. And based upon the line length, based upon the distance, we are boost up the voltage with the help of step-up transformer. With the help of step-up transformer. Again, in the receiving substation, they are step down the voltage. After that, they are sent to the consumers via transmission then distribution line. There is no other options are there. In the last previous semester, purely we are studying about the generation of electrical power. The first unit we are studied the hydroelectric power plant, how we can generate it with the help of water. And the second unit, thermal and then nuclear power plant, how we can generate the power from thermal power plant as well as for the nuclear power plant. In that, the third unit, we have discussed about the renewable energy source. That is the basics of the non-conventional energy source, solar, wind, biomass, geothermal, so on, etc. The fourth unit is economic aspects of the power generation. Once they are generated the power, how we can find out the cost? That is the load curve, load duration curve, and various types, the demand factor, load factor, so on, etc. And the fifth unit is tariff. That is the rate at which the electrical energy consumed to the consumer is called as tariff. Based upon the different types of consumers, the tariff are differ. That is flat rate tariff, black rate tariff, 2-port, 3-port tariff, power factor tariff, so on, etc. But in this semester, we are going to study about the transmission and then distribution of electrical power. Once we have generated the power in the generating session, that is 3.3 kV or 6.6 kV, 11 kV, immediately we need to send to the consumer via transmission and then distribution. We can't store in the power plant. We can't able to store in the power plant. In that, the power plant, we can store with the help of battery. In the market, the available for 12-volt battery and then 24-volt battery. 12-volt and then 24-volt battery. And we can connect it in the series parallel combination. We can store the voltage in terms of volt, not in terms of kilovolt. Again, the battery cost is very, very high. But in the power plant, we are generated the huge amount, that is in terms of 3.3 kV, 6.6, 11 kV, and 33 kV is also there. But in India, we are generating the maximum up to 33 kV. But in US, China, Japan, they are generated 33 kV also. They are generated 33 kV also. But in India, maximum we are generated for the 11 kV. We can't be able to store this much of the voltage. This much of voltage. We can store in terms of voltage. That is only for the certain limit. But in the power plant, the power generation in a day 24 hours, in a month 30 days, in a year 365 days. Once we are generated the power, immediately we need to send to the consumer via transmission and distribution line. Again, here the supply system are classified for two types. One is for AC supply system, another one is for the DC supply system. One is for the AC supply system, another one is for the DC supply system. That is the first unit is transmission line parameter. What are the parameters in the AC transmission line? That is three parameter. One is for the R, L, another one is for the C. That is resistance, inductance, another one is for the capacitance. But in the DC transmission line, only the parameter is available for the R. The inductance and capacitance are eliminated. The inductance and capacitance are eliminated. Due to the inductance and capacitance, the losses are more. That is the transmission line loss, I square R losses, skin effect, proximity effect, spirality effect, corona, so on, etc. This all the problem is occurred due to the inductance and capacitance. Due to that, in the AC transmission line, the losses is more, but in the DC transmission line, the losses is very, very less. But the maximum in India, we are depending only for the 99%, the whole of home appliances as well as for the industrial appliances. Even though in the DC system, why we are not preferred means this is only used for the electric traction. Used for the electric traction. Recently, in the electric traction also they are used for the AC supply. They are used for previously they are used for the DC series motor, but at present the electric locomotive they are used for the induction motor. They are coming from the AC system. Now, how here that is the power generation is represent for the PG, the power demand is represent for the PD, and the power loss is represent for PL. Before 20 years or 15 years back, that is the power generation is greater than the power demand. That is the generation is maximum, the demand is less, including the line loss, that is I square R loss. The slightly before 5 or 8 years back, the power generation is approximately equal to the power demand plus power loss. But at present situation, that is last 2 to 3 years back, that is the power generation is less than the power demand plus loss. The demand is increased, the generation is constant, the demand is increased, because at present almost all we are depending for the electricity. Early morning we are wake up to go for the bed, all the work we are depending maximum 95 to 97%, we are depending for the electric energy. Why the demand is increased means day to day the population is increased. At the same time, the technology is well developed. All the appliances we are utilized, it required for the electrical energy. The input, the primary supply is required for the electrical energy. For example, you can take the early morning we are wake up, they are used for the electric cooker or electric stove, they are used for the greaser, washing machine, refrigerator, so on, etc. From all the things, the input required for the electric supply. That is the population is increased, at the same time the technology is well developed. Those appliances we are utilizing, the primary thing required for the electricity. Due to that, the demand is increased, but the generation is constant. But we need to satisfy for the consumer. In that, the power system, the main objective is we need to satisfy for the consumer in two aspects. One is for the quality, another one is for the quantity. One is for the quality, another one is for the quantity. Quality means we need to give for the consumers without interruption and without load fluctuation. That is, we need to satisfy for consumer two parameters. One is for the quality, another one is for the quantity. One is for the quality, another one is for the quantity. Quality means without interruption and without the load fluctuation, we need to supply for the consumer. Quantity means at reasonable price. Now, here the demand is increases, but the generation is constant. Where we need to satisfy, we need to minimize for the losses. That means we can concentrate for the inductance as well as for the capacitance. Once we are minimizing the losses, we can satisfy for the consumer. Suppose if you go for the extension of the power plant, again the cost is increased. That burden is presented to the consumer. Again, we need to concentrate for the quantity at reasonable price. Again, here we are extending for the power plant. The cost is increased, the per unit cost. That burden is presented to the consumer. Again, the consumers are not satisfied. This is the main objective of the power system. We need to satisfy for consumer the two parameters. One is for the quality, another one is for the quantity. Quality means without interruption, without load fluctuation. Quantity means at reasonable price. In the first unit, we are going to study about the transmission line parameter. That is, we are discussed about resistance, inductance, another one is for the capacitance. For single phase, what is the effect? For three phase, what are the effects? And three phase, again, it is classified for two types. One is for symmetrical system, another one is for the unsymmetrical system. Now you can see this is the structure of the power system. In that, the power plant, we are generating the power. In the power plant, we are generated for 3.3 kV, 6.6 kV, 11, and then 33 kV. Once we are generated the power, we need to send to the consumer via transmission and then distribution line. Again, here we are using for the generating transformer, that is step up transformer. The step up transformer we are using only in the generating station. Remaining all the places we are used for the step down transformer. Here, this 3.3 or 6.6, 11 kV, we are step up into based upon the line length, based upon the distance, that is 66 kV, 132 kV, 220, 400, or 765 kV, based upon the line length or based upon the distance. Again, the primary transmission line, again, it is classified for two types. Transmission line, again, it is classified for two types. One is for primary transmission line, another one is for the secondary transmission line. How it is classified primary and then secondary transmission line? Based upon the operating voltage. In primary transmission line, the operating voltage is 132 kV, 220, 400, and then 765 kV is represent for primary transmission line. In secondary transmission line, that is represent for 33 kV and then 66 kV. Based upon the operating voltage, it is represent for primary and then secondary transmission. In primary transmission line, the bulk amount of power is transferring. There is no tapping is available. But in the secondary transmission line, the operating voltage is 33 and then 66 kV. Only few tappings are there. That is only for the industrial consumer. Again, similarly, the distribution line, again, it is classified for two types. One is for the primary distribution line, another one is for the secondary distribution line. In primary distribution line, the operating voltage is 11 kV. In secondary distribution line, the operating voltage is 440 volt. 440 volt. That is three phase, three wire system. Three phase, three wire system, primary transmission line. In secondary distribution line, that is three phase, four wire system. Three phase, four wire system. How they are classified means based upon the operating voltage, based upon the line length. Now, only they are used for the step up transformer in the generating station. Remaining all the places they are used for the step down transformer. In the primary transmission line, that is this 3.3 or 6.6, 11 kV, they are step up into 66, 132, 220, or 400 kV or 765 kV. In India, the maximum the operating voltage in the transmission line is 765 kV. In India, that is the maximum operating voltage in the overhead transmission line is 765 kV. That is in the primary transmission line based upon the line length. Suppose here they are transfer either 132, 220, 400 or 765 kV. Again, they are step down the voltage with the help of step up transformer. This 765 or 400 kV to 220 or 132 or 66 kV. Again, in the secondary transmission line, the operating voltage is 66 kV or 33 kV. Here only few consumers are there. That is few tapping is there. That is only used for the industrial consumer classified three types. One is for the bulk industrial consumer, medium power consumer, low power consumer. The bulk industrial consumer they are taken for the 33 kV. Again, in the consumer premises, they are kept for the step down transformer. Based upon the requirement, they are step down into 11 kV. They are used in the consumer premises. And in the secondary transmission line, the terminal end, again, it is for primary distribution system. In the primary distribution system, the operating voltage is 11 kV. That is the 66 or 33 kV step down into 11 kV with the help of step down transformer. Again, in the primary distribution line, the tapping is only taken for the few distribution substation and then medium industrial consumer. Medium industrial consumer. Again, they are kept for the step down transformer in the consumer premises, industrial consumer premises. This 11 kV step down into 440 volt or 400 volt. And again, the secondary distribution line, the only that is the 11 kV, again, they are step down into with the help of pole mounted transformer or distribution step down transformer. This 11 kV, they are step down into 440 volt or 400 volt. 440 volt or 400 volt. N number of tapping is available. N number of tapping is available. This is the structure of the schematic diagram of the power system. That is in the generating station, either conventional or non-conventional power plant. Once they are generated the power in the power plant, either thermal power plant, nuclear, gas or diesel power plant, they are generated in terms of 3.3 or 6.6 or 11 kV. 3.3, 6.6, 11 kV. This the generated power, they are connected into the step up transformer. Based upon the requirement, they boost up into 66, 132, 220, 400 or 765. Again, based upon the operating voltage, it is classified for two types. One is for the primary transmission line, another one is for the secondary transmission. In primary transmission line, that is high voltage operating line, that is 132 kV, 220, 400 and 765 kV. In the secondary transmission line, operating voltage is 66 or 33 kV. With the help of step down transformer, they are step down the operating voltage. They are step down the operating voltage, that is 400 or 220 or 132 kV to 66 or 33 kV. In the secondary transmission line, few tapping is there only for the bulk industrial consumer. Again, the distribution line are classified for two types. One is for the primary distribution line, secondary distribution. Again, based upon the operating voltage, it is classified primary as well as for the secondary. In primary distribution line, the operating voltage is 11 kV, connected for the medium industrial consumer, and the secondary distribution system 440 volt, used for the domestical purpose, domestical irrigation purpose, domestical irrigation purpose. Now, you can see this is the schematic diagram of the generating station, the only used in the power plant step up transformer. Remaining all they are used for the step down transformer. Step down transformer, that is the generating station is constructed far away from the consumers, far away from the consumers. With the help of step up transformer, they boost the voltage. Maximum in India, the transmission line is 765 kV. They are transferring the voltage. Again, this is primary transmission line, secondary transmission line, and the distribution is classified for two types. Again, the step down transformer, primary distribution system as well as for the secondary distribution system. In primary distribution system, the operating voltage is 11 kV, and the secondary distribution system, the operating voltage is 440 or 400 volts. In this class, we have discussed about the glance of the previous semester, generation of electrical power, what we are studied, and the transmission and distribution of electrical power, the overview of the syllabus, the 5-unit syllabus, and discussed about what is the layout of the power system, what is the generation of the power plant, how we can classify it into primary as well as for the secondary transmission system, how it is classified for the primary and then secondary distribution system. It is classified based upon the operating voltage, based upon the operating voltage. Up to any doubts?